All right, let's talk about the Go Formative Practice Assessment. First question, which is not a property of an acid? pH lower than 7. No, that's true about an acid. Turns universal indicator blue. That's not a property. It actually turns it red. Yep, and acids taste sour and they're corrosive. Which of the following substance is most likely to be an acid based on their Arrhenius definition? Well, acids typically start with an H, honestly, by both definitions. So it's that first one. This would be neutral for the record because it doesn't have H or OH. This would be base, and this would also be neutral, salt. Which of the following best describes a base? Select all that apply. A base forms a salt when placed in water. No. A base adds hydrogen ions. No, that's an acid. A base adds hydroxide ions. Yes. A base can rip a hydrogen from another substance. Yes. It's a Bronsted-Lowry base. Which of the following is true about HCl, a strong acid? It will completely dissociate and have a low pH because acids have a low pH. And completely dissociate means break up. Which of the following solutions would have the largest hydrogen ion concentration? That means it's the most acidic. So it would be the one with the lowest pH. If a solution has a pH of 4, that means the hydrogen ion concentration is 1 times 10 to the minus 4th. So that would be 0.0001. If you take a sample of concentrated acid and dilute it with water, what happens to the pH? Well, the pH of water is 7. So it's going to start off low, like maybe the pH equals, I don't know, 1. And then if you keep adding pH 7, pH 7, pH 7, the pH will increase, eventually reaching 7. Which of the following are the correct products of this neutralization reaction? So we know we always make water. So we've got a base plus an acid. And what else is going to be left over is Na and SO4. Na is a +1, SO4 is a -2, so the answer would be Na2SO4. 25 milliliters of 0.1 molar HCl is mixed with 25 milliliters of 0.1 NaOH. So we're adding equal amounts of equal concentration of 1 to 1 molar acid and base. That means the pH is going to be 7. Your friend shows you her work for a titration calculation for the following question. It takes 55 milliliters of H3PO4 to neutralize 400 milliliters, just going to divide by 1,000, of a 2 molar solution of NaOH. So what's the concentration of the H3PO4? Let's see. So that's our mystery. So first step, she did 0.4 times 2. That makes 0.8. For every 3 moles of NaOH, you make 1 mole of H3PO4. That's good. Uh-oh. Then she's supposed to do moles divided by liters to get the concentration. So she went wrong on the last step. It should have been divided instead of multiplied. This is our last one. Last one. You've got a beaker containing 600 milliliters of BaOH2. I'm just going to divide by 1,000. That's 0.6 liters. You find that it takes 0.175 liters of a 0.8 molar HCl to neutralize. So what's the concentration of BaOH2? Okay, let's see here. BaOH2 plus 2HCl makes BaCl2 plus 2H2O. So let's write what we've got. So we've got 0.175 liters, and the concentration is 0.8 molar. And we know we had to add 0.6 liters. We don't know the concentration. So first step, multiply our two knowns to get how many moles. So 0.175 I can't type this for some reason. There we go, times 0.8. That's 0.14 moles of HCl, okay? For every 2 moles of HCl, it's neutralizing 1 mole of BaOH2. So essentially we're dividing by 2 here. So that's 0.07 moles of BaOH2. Divide by the 0.6 liters to figure out its concentration. Answer, 0.12 molar BaOH2. There you go. That is it.